Hello YouTube viewers, welcome to my show Science Thursday. In today's episode we're going to take a look at another source of power, geothermal energy. So let's dive right into it. So what it is basically that is heat inherent to earth itself. Basically it's heat from down under. So where does that heat in the first place comes from? Energy cannot be created nor destroyed. So first source of energy that is that many of you know that star creates what's called accretion disk. Like there is a disk around a star that combines and becomes planets. Now that when that happens, lot of energy is conserved in form of heat. That's why all the planets generally end up with a orbit that is more or less high. You don't have an orbit that is going like this, one another planet going like little bit up and down is possible, but you more or less you will end up with a disk-like system. So when that happens, lot of energy is being conserved and lot of impact damage that is happening because of gravity. Many of you have heard of something known as late bombardment period. That happens because once Earth become big enough, every small rock gets attracted towards it, so that's like dumping a lot of heat energy into it. Now what happens to that heat? Because Earth is in space which is a vacuum, it's insulated from everything. There is nothing to conduct that heat away, so that heat gets trapped inside. Now it starts to cool from the outside, obviously. That's why we have crust is the first thing that cooled. Now crust itself is cooled, atmosphere itself cannot radiate too much heat away, so this takes millions and millions and millions and millions of years to actually cool down to the core point. So till then we have infinite source of energy, or basically as long as Earth is there we have this source. Second, the energy is coming from, it's what's called radioactive decay. Basically when you have uranium, it gives off a little bit of radiation. Now imagine hundreds and thousands of megatons of uranium and heavy elements being here, that is dumping the, it's not that much. If you take 1 kilogram of it, it's not giving that much heat, but when you have Earth size kind of object where you have gigatons of it, it produces enough heat. So these are the two source of heat that's giving heat to it. It's not solar, do not mistake it by solar. Solar does affect how quickly it cools down or how slowly it cools down, but it is not the source of it. This is independent from solar. Now many of you inherently know this geothermal energy by hot springs. So why we have so much interest in it? First, it has very little to small environmental impact. Now you might be like, okay, why there is an environment impact if we are using this? And I don't mean energy you need to make this infrastructure. I mean it inherently releases carbon dioxide. Now you're like, where is that carbon dioxide coming from? That carbon dioxide is trapped in Earth. There is many other impact also. Methane would be released. Many things get trapped underground, and if you drill down there is a risk that you can release them, and over time you do release them. Like, of course it's nowhere near, like let's say for 1 megawatt you have to release let's say 1 ton of CO2. Here it's invert of that. It's like for 1 megawatt you are barely releasing 10 kilograms of CO2. So inherently in comparison, on balance, it's a very, very small fraction, but it is there. It's not zero, it's not solar, it's not zero. It has some footprint, and it's an ancient technology. The oldest that we know of, like there may be older than that, is from Chinese dynasty, that is from 300 BC. So suffice to say, from very old time we know that. And this has one unique ability that very few green power can provide. It's what's called 24/7 power, base load capacity. Basically it can give that much power and be done with it. It's like it's gonna give you 800 megawatt no matter what, depending on your plant size. So how does it work? Well, it's very crucial. As this stage of humanity, we are very location dependent. Basically you have to have nature helping you out here. Now where these hot springs are, it's kind of random. Sometimes they appear near a tectonic fault plate, sometimes happens because of volcanoes. So there is a lot of natural element to it. It's not just like you can just go anywhere and drill. If you can drill very deep, then it's not an issue, but most we don't have the technology yet to do so. So at this point we are very location dependent. That's why you will hear Iceland, Philippines, all those places coming, because they somehow naturally ended up in a place where they have a lot of geological activity which is giving them hot springs. Then once you find the location, you drill. Now this drill is not your normal water drill. This goes very deep, upwards of 2 to 3 kilometers, sometimes even deeper than that. And the bore diameter is also carefully calculated to maximize the energy output. And then you set up a power plant. The power plant setup is kind of bit different here, because many of this power plant, what they do is like they pump water directly into that well, and that well starts to heat that water, and then they have what's called drain well. Basically they are injecting water from one point, it's heating it up, steam is coming out from two other wells. So it's kind of open cycle system, and that also creates another risk that it can create earthquakes. Not very powerful earthquake, but minor earthquakes, as in Richter scale 3. Most buildings can withstand it without any issue, but it does make it geologically active because of that water creating pressure at that place where there is no water. So it's kind of very unstable. But if you have natural formation, as in like it already is a magma chamber there, then you can draw electricity out of it without causing major ecological damage. So if we have all these things, what kind of power can we expect? USA, Philippines and Iceland, they are kind of leading the charge. USA is not leading the charge because even though it has the biggest power plant there is, the Glacier in USA, problem is that it provides very small fraction of energy of USA power's consumption. And in case of Philippines, Philippines gets upwards of 17% of its total energy from geothermal. That's why you will hear people say Philippines and Iceland, because they're getting larger proportion of their overall electricity from geothermal. But if you talk about raw power, like raw megawatts, USA is still in ahead, and second power plant is like 225 megawatts. And suffice to say, this power plant, you may find this number to be quite small, and it is true, because modern solar cell farms that I have made a video about, it's already reaching a point where we are making 800 megawatt, 2000 megawatt, 20,000 megawatts. So suffice to say, it's not as powerful as we think. So, but it still provides a unique source of energy. Now, what we can expect in the future, it's very simple. We want to reduce emission by any and all means possible. So older designs were not taking into consideration the emission that used to happen because of this. It was so little that they didn't care. Now they do care. Now they're like, okay, let's reduce that CO2 emission. Let's try to make sure if methane starts to come out, they burn it, because carbon dioxide is a lesser of two evils basically. So we will burn the methane, and there is arsenic, other things, mercury, things starts to come out. So we have to filter it out. We don't want to directly release into the atmosphere. So we are making sure even the old power plants that have been working for 20, 30 to 50 years, they are getting new smokestacks to clean those things out. And we have to create it in such a way. Iceland recently was making a very big plant, and the problem, they cancelled it because they started creating earthquakes. Now, not big powerful earthquake, you may not even notice it if you are in a car or things like that, but it did started to create an unbalanced scenario. That happens because we started using fracking, the fracking technology that we use for oil extraction, and it has the ability to destabilize a localized area. It's not gonna cause a cataclysmic level earthquake, but it can destabilize local regions. So for that reason, we have to do better studies in this. And the final nail in the coffin why geothermal is not becoming as popular as it could be is because of its low efficiency. Basically, to extract the power out of it, at the end of the day, I always specify money talks. So because of this low efficiency, that means if you spent whatever money you spent, let's say $1 billion to build a plant, it will take very long time to get that $1 billion back. And not to mention, things break, you need maintenance money, you need replacement money, as in like any component breaks down. You also need to pay for staff, you also need to pay for taxes, you also need to compensate for inflation. So this efficiency is very serious bottleneck. We can have a lot more power from geothermal, but we cannot, because it does not have enough efficiency. But it is profitable. Any company or country that does that, most places it is profitable. It's just not as lucrative as solar. As I already mentioned in my solar video, that solar is reaching price parity. This is far from it. However, it does provide baseload capacity. So this was my small presentation on geothermal energy. I hope you liked it or learned from it. In that case, please leave a like. If you didn't, dislike it, and leave a comment what you want to see in the next episode of Science Thursday. And I would suggest you subscribe and press the bell icon, as I make video every day. And as always, thanks for watching.